Hello, Colonet Africa online students. Welcome to our 8th lesson in this topic of salts. In this lesson, we're going to discuss or to look into the action of heat on salt, what happens when salts are heated. And in this 8th lesson, we are going to tackle the action of heat on carbonates. Heat energy can bring about change in substances when applied to them. You can have an increase in mass or a decrease in mass depending on the type of the compound that you are working with. The following experiment demonstrates the effect of heat on carbonate, nitrates, and sulfates. Action of heat on carbonates. We are going to look at experiment 4.11. What is the effect of heat on carbonates? Put half a spatula of sodium carbonate in a test tube. Heat the sample gently and then strongly until no further change occurs. Test the gas given off by placing a glass rod which has been dipped in calcium hydroxide solution at the mouth of the test tube. Record your observation as shown in table 4.6. Repeat the same experiment using the carbonates of potassium, calcium, zinc, lead, ammonium, copper, and hydrogen carbonate of sodium and potassium. This is our table 4.6, and this is the table that you're supposed to record your observations. The color before heating, we have the carbonates, calcium carbonate, sodium carbonate, potassium carbonate. You have to indicate the zinc carbonate, also the calcium carbonate. So we have the calcium carbonate there, lead carbonate, ammonium carbonate, copper carbonate. This is a P, it's not double O. This is COPPER because it's copper. Then we have color before heating and color after heating. Effect on calcium hydroxide solution, that is the gas that may be produced. You test that gas on calcium hydroxide solution. Then you repeat the same using now the hydrogen carbonates of sodium and potassium. They are the only solid hydrogen carbonate that do exist. That is sodium hydrogen carbonate and potassium hydrogen carbonate. The other carbonate do not exist in solid form. Then let's look at our discussion. Pure carbonates of sodium and potassium are not affected by heat. Carbonates of these metals are stable. That's the carbonate of sodium and potassium. They're very stable, and therefore you're going to find that even if we heat them, there will be no change. If hydrated, the salts only lose their water of crystallization. For instance, the sodium carbonate decahydrate, it's gonna lose only the 10 molecules of water of crystallization, but you're going to find that the resulting white salt will not undergo any further change. And if it has the water of crystallization, the water of crystallization will condense at the upper part of the vessel that you're using to heat your salt on. And you can test that water using anhydrous copper 2 sulfate, which is normally white. And once you put water on it, it's gonna change into blue. The water vapor condenses on the sides of the test tube as a colorless liquid. The residue is a white solid. Sodium carbonate decahydrate, if you heat it, you're gonna get sodium carbonate plus water of crystallization. That's the chemical equation. So you're only losing the water, the 10 molecules of water. That means you're going to have the residue will have less weight. This compound, the decahydrate, which is a solid, will have more weight than the residue that is obtained because you're losing the water of crystallization, and that water has weight. So you're going to have a decrease in mass. The other metals, carbonate, decomposes on heating to give off a colorless gas, and the corresponding metal oxide. And this colorless gas is carbon 4 oxide. So you get a carbon 4 oxide and the metal oxide. On testing the gas with calcium hydroxide, a white precipitate is formed, confirming the gas to be carbon 4 oxide. The white precipitate is as a result of formation of the calcium carbonate, which is an insoluble salt. Calcium carbonate, if you heat, you get calcium oxide plus carbon 4 oxide. This is the chemical equation. So you decompose this one, you get calcium oxide plus carbon 4 oxide. Remember, this has lost some CO2 from the original solid. That means the residue has less weight. So we have a decrease in mass of the product. Zinc carbonate, if you heat, you get zinc oxide plus carbon 4 oxide. And this is the chemical equation. So we have zinc carbonate, you get zinc oxide plus carbon 4 oxide. This is a colorless gas. And if you bubble this in calcium hydroxide solution, you get a white precipitate, which is a test for carbon 4 oxide. Let's see. Zinc carbonate is white in color originally. If you heat it, you get zinc oxide. And this zinc oxide is yellow when hot. When you cool, you get a white solid, which is still zinc oxide. So if you have a zinc oxide solid, if you heat it, you obtain or you get a color change from white to yellow. If you cool it, you get a color change from yellow to white. That's not a chemical change, it's a physical change, because we only have color change. But this decomposition is a chemical change. You're decomposing to form new products. A chemical change is accompanied by the formation of new product. A physical change, however, is only accompanied by change of state or color. And in this case, if you heat zinc oxide solid, you get a yellow color. Once you cool it, you get white color, which means that's a physical change. Mind you, this color is very important because it is only zinc oxide that will give you yellow when hot and white when cold. Then let's look at lead carbonate. If you heat lead carbonate, you get lead oxide plus carbon 4 oxide. Again, if you look at lead carbonate, it's a white salt or a white solid. When it is hot, it's still white, but when you cool it, you get a knowledge solid. So it's orange when cold. Then copper carbonate. Copper carbonate is green in color. If you heat, you get copper 2 oxide, and copper 2 oxide is black in color. So you have a color change from green to black. And carbon 4 oxide is also obtained. My dear, you cannot be able to get this color back once you cool, because this involves a chemical change and you're getting new products. Then the general equation for the decomposition of metal carbonate is metal oxide plus carbon 4 oxide. The position of the metal in the reactivity series determines the ease of decomposition of its carbonate. Thus, the carbonates of sodium, potassium are stable and do not decompose on heating. Those of the other metals decompose with increasing ease down the reactivity series. Ammonium carbonate decomposes to form ammonia gas, carbon 4 oxide, and steam. Those are the products that you obtain if you decompose ammonium carbonate. Presence of ammonia is confirmed by the turning of moist litmus paper to brew. Remember, ammonia is base, so it's gonna change the rare litmus paper to brew, or rare litmus solution to brew. Then this is the decomposition of ammonium carbonate. If you decompose ammonium carbonate, you get ammonia gas, carbon 4 oxide, and water. You can test this gas by introducing a red litmus paper, moist litmus paper. It has to be moist. if you introduce a lead moist litmus paper, it's gonna be changed to blue, since ammonia gas is basic, or it's basic. Carbon 4 oxide is tested by bubbling it in calcium hydroxide solution. It's gonna form a white precipitate, and this can be tested by two tests using cobalt chloride, anhydrous cobalt chloride, or anhydrous copper sulfate. Carbonates and hydrogen carbonates are salts of carbonic acid. There are two solid hydrogen carbonates, namely potassium hydrogen carbonate and sodium hydrogen carbonate. They are the only hydrogen carbonates that are solid at room temperature. The other non-hydrogen carbonate exists only in solution, namely calcium hydrogen carbonate, it's in solution form. Magnesium hydrogen carbonate, it's also in solution form. Three products are formed whenever hydrogen carbonates are decomposed by heat. We have, for instance, if you have potassium hydrogen carbonate and sodium hydrogen carbonate decomposes to give metal carbonate, water, and carbon 4 oxide. This metal carbonate cannot decompose further. Sodium hydrogen carbonate, you heat, you get sodium carbonate plus carbon 4 oxide plus H2O. The same case with potassium hydrogen carbonate, you get a carbonate, CO2, and H2O. These cannot break further because it's a very stable carbonate, as we found earlier on. The hydrogen carbonate of calcium and magnesium exists only in solution form, whereas hydrogen carbonates of aluminum and iron do not exist. They do not exist. That brings us to the end of our 8th lesson. So you have the assignment 8 is testing on the action of heat on the carbonate. So answer all the questions in this section or in this assignment. You can use the answers provided in the Word document accompanying this video to mark for yourself. Ensure that you do the questions, don't copy from the notes. Integrity is paramount. It actually tests how you are able to comprehend the concepts of this particular lesson. So we meet next time for our 9th lesson in this topic. Bye and have a good one. All the best.